So do we have any coffee drinkers in the house? Any coffee drinkers? Yes. I'm not addicted to coffee, but if I do not have it, my day is ruined. I always start my day, though, by going downstairs and getting the coffee maker going. What that entails is I will, grab the filter, I'll throw that in the maker, I'll grind up some beans, I'll throw those beans in the filter, and then I will press that button and walk away. I want to do something else, like feed the baby, maybe have some food myself, right? There are other things that I want to do while I'm making that coffee. I then come back maybe 10, 15 minutes later, grab my coffee, drink it, and now the day isn't so bad. You might be wondering, what the heck does this have to do with background jobs? And hopefully by the end of this talk, you will understand exactly what I mean. I'm Jake. I'm a software engineer at Weedmaps. If you are not familiar with Weedmaps, we are the leading technology and software infrastructure provider to the cannabis industry. We are also a sponsor here, so definitely come and check out our booth. We got some great swag to give away. We are also hiring, so if you're interested in working with us, go ahead and check out the careers page. You can see some job postings there. But today's talk outline, there's really 5 main things that I wanted to kind of talk through today to get an understanding of background jobs, what they are. Before I do that, though, I just want to preface that this is really meant for people getting into background jobs. If you are super familiar with background jobs and you're like, I'm running so many background jobs, I need help, come talk to me after the talk. I'll help you with that later. This is definitely more catered towards understanding what they are, why they are, as well as kind of some of the cool things that Active Job actually gives to us. But we're going to run through this through 5 steps. First, we're going to simulate a problem and try to kind of give us a single starting place to build off of. We're then going to kind of prospect a little bit, dig a little bit more into that problem, and maybe ask a couple leading questions. From there, we're going to investigate and say, OK, well, are there solutions out in the world for this particular problem? We're then going to try to fill some of our knowledge gaps with Rails and say, hey, this solution might exist out in the world, but does Rails itself have an implementation of this solution? And last but not least, we are going to expand on that knowledge and try to learn as much as we can about anything that might be in Rails. Coincidentally, this spells spike. This has nothing to do with the agile term spike. I wanted it to be related to that. I do think of spikes similar to this. Fun fact, spike is not actually an acronym for anything. So I'm going to throw this out there as a potential option for spike. So what is the problem, right? Where's the starting point here? Well, let's start with a Rails request. I'm going to have some diagrams here on the side with little animations to try to provide some context of what the heck I'm talking about. You've got a router that determines a controller and an action to render, OK, and then that goes to the controller, which is then going to request data from the model. The model's going to talk to the database. Database is going to return stuff to the controller, so on and so forth. The controller sends stuff back to the visitor of the site. But the most important thing that I want to highlight here is that we need each one of these steps to complete before moving on to the next, right? We can't go to the controller if the router doesn't tell us to go to that controller, right? We have to wait for each of these things to complete. This is also by no means what a full request is in Rails. If you want to learn more about that, Skylight did a RailsConf talk on this, and they also has some accompanying blog posts. So check those out if you want to learn more about Rails requests specifically. Oh, look at that. We got a new product request. Surprise, surprise. They would like to add a change that requires some more logic in this controller. We're going to simulate that with a service class. For those who aren't familiar with services, think of a regular Ruby object that will take in some input, do something fancy with it, and maybe output something else. Examples of this might include sending an email, or updating a counter somewhere, or maybe doing some kind of account setup, like maybe you got to hook up to Stripe and send some stuff over there. Really, it's anything, right? It's whatever is specific to your business needs. But the important thing here is we have added another thing in our request chain, right? We are now reliant on whatever this service is doing, and our visitor is now relying on that too. Oops, service is taking too long. Maybe that's HTTP. You're trying to send out that email. Your email server is down. It's not working. You're SOL. Maybe the database is getting too much traffic. It's late in the day. Everyone's trying to wrap everything up, and things are slowing down. Your service is slowing down. Maybe the service just does a lot of things, and it takes a few seconds anyway just to complete all of those tasks. The visitor, though, is still there. They are waiting, and maybe they are leaving in anger because you are taking so long to solve this product request. So what might this look like in Rails, right? You had some little diagrams there on the side with a ball going up and down, but what does that actually look like? For this example, I've got a pages controller that has an index action. Imagine this is like a home page. And on the home page, we're going to call some service that's going to print a message to the screen. This some service is our plain Ruby object. It has a perform method. It's going to sleep for 5 seconds just to simulate a little bit of work. And then it's going to put that message to the screen. Our terminal output would look something like this, right? I tried to highlight the printed message in green. It actually came out in white. I don't have any fancy thing that puts that in green. So there's that message. But some of you may have also noticed it took over 5 seconds for us to complete this request. And all we did was print something to the screen. Did the user need to wait for that? That's the question. So let's dig a little bit further. Let's bring back that coffee maker example, right? Here's kind of a similar chart to the requests, right, but in coffee maker terminology. So you've got an uncaffeinated person, right? They're desperate. They need to place that filter in the machine. They push the button to grind the beans, get things going. They're waiting for the beans. They put it in the filter. And now they push that start button, right? But now they're just sitting there. They're waiting for the coffee maker. They're just like eager. I need the caffeine. And so they sit there and they wait for that coffee maker to finish brewing. And once it does, they grab their coffee, they drink the coffee, and they move on. Again, similar to our hanging request. But like me, I don't want to sit there and wait for my coffee. I've got other things that I want to do, right? Same thing with this Rails request. It has other things that it wants to do too. I want to render the view. I want to move on to other requests. So do we have to wait while the coffee's brewing? No. So do we have to wait on this server call? If yes, OK, well, maybe we do have to wait on it. Like we have to wait for the filter. We have to wait for the beans to grind, right? We can't start the coffee machine until we at least have some of the pieces together. So if we do have to rely on it, can we make it faster? Or are there ways to re-architect some things to make it so we don't have to do it right now, and something else can gather the filter and the beans later on, but we just tell it, hey, by the way, you got to grab the filter and the beans. But if we don't have to wait on this, like in our puts example before, the user doesn't care about us logging some information, right? So can we essentially, in coding terms, can we like push the button and like come back to it later? So now let's investigate that idea a little bit more, right? Surely somebody has thought of this, right? I can't be the only one that's like, can we just do these kinds of things later? And yes, this has been solved. This is background jobs and async processing. Welcome to my talk. That, in a nutshell, is what background job processing is. So what does this look like at a really high level? So you're going to have a service, right, that gets added to a list. We're going to call that list a queue. And it's going to come with any associated arguments. So in this case, the queue is just some random class, just pretend it's a queue, and we're going to add something to that queue. And we're going to add the class SomeService, right, just like we did in the controller. And we're going to give it the hello RailsConf message. So that's going to add it to the queue, that list somewhere. And that list might look something like this, where, hey, we've got a couple things already in that list. You know, the SomeService with I'm the first job, SomeService with that makes me the second. And now we just added that third one to the list to process of SomeService hello RailsConf. After that, we're going to there needs to be something to kind of run and pull these things off of this list, off of the queue. And so the job is going to be equal to, we're going to call that a job. We're going to grab the first thing off of that list. We're going to grab the class, which is going to be the first argument right there, that SomeService, which is a string. And then our arguments are the second, right, that hello RailsConf. So what we need to do then is we need to take our string class, and we need to turn it into Ruby class. You can do that with the .constantize method. We need to create a new version of this class. We need to instantiate it, so we'll call new. So now we got SomeService.new, right? And now we call the perform method on it, just like we did in the Rails controller. And then we can splat in those args. For those who aren't familiar, Ruby gives you kind of a splat operator that works very similarly to the JavaScript splat operator, if you're familiar with it. So definitely check that out if you're not familiar. But what does this actually help with? Like, cool, you did some research, people push things to this queue and like pull it off this queue. But like, why? Why does that even matter? Well, one thing is it prevents too many things from running at the same time. So let's think really quick back to the controller example. If all of a sudden I just like threw that in the background immediately to process. If we had 100,000 people that came onto our page at the same time, and now we just triggered a whole 100,000 things to run in the background, those are theoretically happening at the same time, we're going to take down our own system. That doesn't seem very smart. So one thing that adding stuff to a list or to a queue does is it allows us to have a little bit more control in terms of how many things are running at a given time. I can say, hey, I want you to pull one item off the queue at once. Maybe I have two different things that are pulling off of the same queue. And it's like, oh, you can have the first one, and then you can have the second one. Don't worry, I'll go take the third one. But since everything is in a list or in a queue somewhere, we can then also see anything that's currently running, right? We can also see jobs that are waiting to run, right? Or perhaps things that have completed successfully, but more importantly, maybe even things that have failed. And since we still have references to the job class and the arguments that that job needed to run, we can theoretically retry that job whenever we need to. Maybe we introduced a bug in that worker or in that job, and we can make some tweaks, push up that change, and rerun it later. The main thing that this queue gives us is stability and visibility. All right, so we had our problem, right, which is the blocking requests. We kind of dug a little bit further to be like, OK, we don't probably need to block the request for this case. It seems like from a software engineering perspective, someone has come up with this idea of queues, right? So let's fill our knowledge of what Rails might have for this. So for those who may not be familiar, Rails has something called active job for managing and processing queues. And it really only requires 3 basic steps to get up and running. 1, we create our job class. 2, we tell the job class to essentially add itself to the queue. And then step 3 is Rails just takes care of the rest with an asterisk, because it's not really a step, because Rails just handles it for you. But let's go through each of those, OK? So creating our job, what does this look like? Let's get a little classy. So we're going to create a new class. Usually, you're creating an application job class that inherits from active job base. OK. If you're familiar with Rails models, it follows a similar pattern to where you might have an application model that inherits from active record base. It's a similar thing, right? Where I could inherit from active job base directly. I don't have to do this pattern, but the pattern is already established kind of from models, and so they've followed that with active job. The second thing that I need to do is, OK, now I've got my application job class, and I created my sum job class that inherits from that. I need to create a perform method on that job. This perform method is what eventually gets called with my arguments when that job does run. And you can see from this example, I'm just taking that message and passing it directly to the service. But sometimes you might want to tell it what queue to run on. So this is also kind of something interesting. You might have more than one queue, right? You can have, or list. And you can name them whatever you want. You might have an email queue, or you could have a notifications queue. You can have an errors queue. But by default, Rails gives you a default queue. In this particular case, I told active job, I want to queue this job as my queue name. So let's talk about actually queuing that job. So we have our class. It's ready to go. It's got that perform method. It knows what queue or what list it's going to run on. Now we need to tell it, hey, go add yourself to that list so that you can actually run later. So really all we need to do is take our sum job. It's going to have a class method available on it called perform later. And then you give it whatever arguments you want to give to the underlying instance of that class. So these arguments may be serialized by Rails. We're going to kind of get a little bit more into that here in a second. But under the hood, again, what's happening is when this job does run, so that queue is going to look like the left is going to have that sum job as that string class. And on the right is going to be an array of those arguments that, just like it was before, it says hello RailsConf. But when that job actually runs, it's going to do the exact same thing that I showed in that example. It's going to constantize some job. It's going to create a new. And then it's going to call perform, passing in that argument. And it's going to look something like this. Rails will also automatically deserialize or retransform the stuff back. Again, we'll kind of get to that here in a second. But a quick note on queuing. This is kind of where active job is like really cool and how it operates. Not only can you add something to a queue, but you could tell it to wait to perform that job. Maybe I don't want to run that job right now. Maybe I want to run it in 24 hours. Like this is a feedback email. I don't want to give someone like, hey, give me the feedback on my product when you just signed up. No, I want them to give me feedback maybe 48 hours later. So I'm going to tell this job, hey, wait 48 hours and then send that feedback email. Or maybe I actually want this job to run at midnight or at 3 a.m. because that's when the traffic is lowest. So I can say wait until 3 a.m. and it automatically will just make sure that job does not run until 3 a.m. I can also dynamically change that queue. Say I have a default queue, but I also have an urgent queue. This person needs this email right now. So I'm going to go ahead and override that queue to say, hey, send this to the urgent queue because I want that to run immediately. You can also set the priority queue. It all kind of depends on how you have your queues or your lists set up. But you could also more or less put something to the beginning of the queue versus automatically putting it at the end of the queue. But let's talk about that hand-wavy kind of Rails just takes care of the rest thing. Like how does Rails actually process this job, right? I added it to that queue. It's sitting there. But how does it actually run? Magic, right? Rails magic runs it. It depends BYOB. This does not mean beer or whatever is backend. Bring your own backend. So by default, Rails keeps these jobs in memory. So it'll go ahead and add it to your RAM and process it off of that RAM. So you technically don't need anything else to get jobs running in the background using ActiveJob. But this has one major flaw. It breaks down when the server restarts or crashes. Anyone use Heroku? Yeah, say goodbye to your jobs, right? Every 24 hours, those dynos will restart. Any job that you had in that queue when that dyno restarted or were being processed when that dyno restarted is gone forever. So really what ActiveJob provides us is a set of building blocks for enqueuing and managing async data, right? With a set of defaults, of course, right? You don't have to bring anything else, though you probably should. It kind of gives us the groundwork to base everything off of, the foundation, if you will. OK, cool. So we've discovered our problem, right? It's the blocking request. We know that we can potentially unblock it. We can put it on this queue. There's this thing, ActiveJob and Rails, that we can use. Now let's talk a little bit more about ActiveJob. So first, what are some of our available backends that we have, right? Like, we don't want to lose our jobs when the server restarts. What can we possibly do? Well, Rails actually has out-of-the-box solutions for a number of different backends, and it's going to depend on the needs of your application and maybe what you're familiar with. I'm going to go ahead and put those up here. Beanstalk, I have no idea what that is, but if you do, you can use Backburner. But if you're using like a database, you can use something like Delayed Job or K or Q Classic. If you want to keep things in memory, you can keep using the async version of ActiveJob. If you use Redis, you can use Rescue, or Sidekick, I hear is pretty popular. And if you use RabbitMQ for sending messages back and forth, there's also out-of-the-box support with Sneakers. One thing I do want to highlight, though, is this list is by no means complete. The Rails team has decided that they're no longer accepting management of these adapters, because all these adapters are built into Rails themselves. And rather than having Rails manage these adapters, it should be up to the libraries to manage those instead. So if somebody might have gone to the talk yesterday that involved Kafka, Kafka is not on this list. So if you want to use Kafka as a backend, it's not officially supported through Rails, but the job is going to probably have an ActiveJob adapter that will work with Kafka. So I just want to make sure that if you're going and exploring the docs, know that you will have, and there probably are, more things available than are what are explicitly listed. You might then be wondering yourself, why not use the library directly? Oh, we use Sidekick. We actually do use Sidekick at Weedmaps. Like, why wouldn't I just use Sidekick on its own? Why do I need ActiveJob? Why add in that extra layer of complexity? What does this give me, right? Well, the first thing is global IDs. For those who aren't familiar with global IDs, it is kind of like this unique URL that points to one of your models. A URL might look something like this, right? It starts with GID instead of HTTP, and then my app is the name of my app. User is the user model, and 420 is the ID of that user. So this allows us to do something like some job, perform later, and just we can give that active record object directly to that class. We don't have to worry about it going and like sending down all these types of things. Whereas before, we might have had to say, OK, I need to give the user class and the ID of the user so that the job can look up that user itself. No, the job doesn't need to worry about that. We can use global IDs. Don't worry, Rails has got it. You got something else that you want to serialize that doesn't have a global ID? No problem. Rails has serializers for that. I stole this example from the Rails guide, so I want to, if you do want to see it, it is there. But in this example, it's the money, right? Some people might be using a money gem. But say when I'm turning this money object into something that the job can understand, I want to say, OK, money, I want you to grab that amount and set it equal to amount in this hash. And then I want you to set the currency equal to currency. And then when you actually take that money object and turn it back into something for the job, I want you to create a new money with amount and hash, or amount and currency as the arguments. And then there's a third method that we have to define called serialize that essentially says, do we want to serialize this class with active job? If argument is a money, then yes. Otherwise, not so much. This one was actually new to me, and I think this is probably the most underrated one, in that is that you get automatic localization with your jobs. So let's pretend, for example, that our app is in English, right? And we are going to run this particular job here in the middle in French. Say our visitor is coming in from France. They're looking at our site. Everything is translated in French. And they clicked a button. Now we're going to send them an email later. Well, ActiveJob will actually keep track of the fact that that was in French. And it doesn't matter if that job runs 5 minutes later, 5 hours, or 5 days later. It's going to keep that in memory. And it's going to know, hey, by the way, when you render that email, render it in French. It's not going to call les job, right? It's the French version of your job. It is going to just know that that job should be using the French language. But outside of that context, you can just call perform later, and it's going to use your default locale. Callbacks, right? This is kind of a hairy topic. If you like callbacks, you don't like callbacks, that's not what I want to get into. But if you do like them, you can use them. They work very, very similarly to active model callbacks in that we get before, around, and after hooks for both enqueuing, adding the job to the list, and performing that job. So I don't know how easy it is to read that code example here, but before enqueue, I'm giving it a little block, and I'm saying, hey, I want you to log a message to the Rails console that says, hey, I'm going to run this class. But then I also have this around perform method that captures the runtime. I want to know, hey, how long is it actually taking for this job to run? How long did it sit in the queue waiting to run? I can get all that information and then also log that out. I can grab right here. You can see I'm grabbing the job start time. We actually do get a couple of methods available to us by using ActiveJob. One being this enqueued at, which will tell us a timestamp of when the job was enqueued. We also get a job ID method that we can use that is a unique ID for that given job. So just given those two things, I can easily say, hey, job ID took this many seconds to run. And since I know when it was enqueued and when the job started, I can know how long it was delayed and can log that as well. ActiveJob also has support for built-in error handling, which is also really, really cool. So pretend, again, in this email example, you had a user, but that user account was deleted by the time that that job ran. So when ActiveJob tries to find that user, it's going to be like, oh, hey, active record not found. And you can tell that job, you know what? If you can't find the record, I don't care. Discard it, delete it, move on. But maybe you're working with an API, and that API has rate limits. And you're like, oh, looks like I hit a rate limiting error. I actually want to tell ActiveJob, hey, if you hit this error, retry it. And it's going to keep retrying on some kind of like back off, kind of where it's like, oh, it's going to retry it in a minute, 2 minutes, 5 minutes, so on and so forth. But it will automatically handle all of that for you. If you want to have some custom logic around how you're handling a particular error that is known, you can call a rescue from. So in this particular case, maybe I'm also using this API client, but I got an authentication error. My token is no longer good. So I need to go get a new token and store that. So in this case, I'm going to rescue from that authentication error. I'm going to go get a new token. I'm going to store that. And now I'm going to re-enqueue this job. And hopefully, it runs the second time or third time. But the main reason to use ActiveJob rather than any other library is, again, this idea that you have a unified API for interacting with jobs no matter the back end. Right? Anyone that uses ActiveJob can go from one Rails app to another And it doesn't matter if you're using Sidekick or Delayed Job or Sneakers as your back end. You're familiar with Active Job. That abstraction is taken away from you. So you can just focus on writing code that you are familiar with and leave the details for downstream services. So I'm a little over time, so I'm going to give just some parting thoughts here. Where do you go from here? So how is this related to making coffee, right? We might always need to grind our beans and put them in the filter. There are going to be synchronous things that we have to do and we cannot avoid. That's just a fact of writing software, right? But we can push the start button on some of our coffee and come back to it later. Like, there's no need to stick around. There's definitely a lot of code. I'm sure there's code you're thinking about in your own code base that you're like, we probably don't need to do that right there. We can probably maybe do that some other time, or re-architect things to do some other time. And you know what? If it doesn't complete, we can always make a couple tweaks and try again. You know, if I forgot to put some water in my coffee maker, oops, when I came back 15 minutes later, it did not make the coffee. So I can always put some water back in, hit the button, come back 15 minutes later, and there we go. Now I got my coffee. Same thing with the code, right? Jobs failed. Oh no, let's go ahead and make a couple changes, push up those changes, rerun those failed jobs, back in a good state. So what other things are you async processing in life, right? You find yourself standing next to the microwave often, just waiting, right? What about code? Thank you for coming to this talk. If you want to talk more on jobs, I will be at our booth. And if you want to go more low level, I'm very happy to talk about that too. Thank you.